Hello and welcome to this Vivado Quick Take video, targeting Zynq using Vivado IP Integrator. In this video, you will learn how to use Vivado IP Integrator to add and configure the Zynq processing system. You will also see the basic user flow and features of Vivado IP Integrator. This training assumes that you are familiar with the basics of Vivado. Experience using Vivado IP Integrator is helpful but not required. For our agenda, we're going to start by setting up a Zynq processing system and then connect a VDMA using IP Integrator. Then we'll add a video sensor processing pipeline in the fabric using a tickle script. We'll use the validate design to run design rule checks on the design before synthesizing the design, and then see the steps to prepare the design for the software developer. Okay, let's get started by creating a new Vivado project. The new project wizard will guide us through this process. We can give our project a name and specify the project location. We'll select an RTL project. We could add any sources, any existing IP, any existing constraints. Here I can select either a part, or in my case I want to select a board. I want to select the ZC702 evaluation board. This board contains a Zynq all programmable SoC device on it. By selecting a board instead of a part, we provide a lot of additional information to Vivado, as you'll see later on with designer assistance and our board automation flow. Okay, so we're all set. Let's create our new project. Alright, our next step is to create a block design. Give our block design a name. Okay, so this is the IP Integrator canvas. So our design is empty. To get started, we can add IP from the catalog. I'll close this to give us a little more space. First IP that I'd like to add is the Zynq processing system. So I'll select that from the catalog. You notice now this green banner is telling me that designer assistance is available. This is partly because of the board that I specified earlier that gave Vivado this additional information. So Vivado is offering to run block automation on the Zynq processing system, so I'll select that. In this step, it's going to run the block automation. It will automatically connect the fixed I/O and the DDR interfaces that it knows are available on this ZC702 board. I can go over here to the regenerate layout to kind of clean up the diagram. You can double click on the Zynq processing system to re-customize the IP. So I want to enable these high performance ports that go between the Zynq processing system and the programmable logic fabric. So I'll select this. I'll enable HP0, which is one of the high performance slave interfaces. Then let's go over to the clock configuration and expand this. You can see that the CPU is going to be running at 666 megahertz, the DDR interface at 533. Let's set up the clocks that go to the fabric here. So let's change this frequency to 100 megahertz, and then I'm going to enable a second clock at 200 megahertz. So what I want to do here is use the clock 0 at 100 megahertz to run my AXI4 light interfaces, and then I'll use the clock 1 at 200 megahertz to do the processing in the fabric. So you'll see the symbol is updated now with the additional ports that I added. Let's regenerate this to clean it up one more time. Now I'm going to add a video DMA to my design. And then the next thing, I'm going to add a AXI4 interconnect. So now I can double click on the AXI interconnect to re-customize it. I'd like to have two slave interfaces because I have a read and a write channel, and then one master interface to connect to the Zynq processing system. You'll see the symbol is updated. Okay, so now let's start to connect some of these blocks and show the connectivity between these blocks. We can start off here with the AXI interconnect. As I get close to a valid connection, you'll see a little green check mark appear. And that means Vivado is running design rule checks as I'm making these connections, and it's actually only allowing me to make valid connections of like types. So now let's connect the read channel right here, and then we'll also connect the right channel. And let's regenerate this. So, alright, so now we can start to see the data flow. It's going to come through our video DMA, and then through the interconnect, and then to the Zynq processing system, off to the DDR memory, and then back. So designer assistance is available, so let's take advantage of that. The Vivado is asking if I want to connect the AXI4 Lite interface on the VDMA directly to the processing system. So I'll let Vivado do that for me so that I don't have to do that manually. Okay, you'll notice that added a few additional blocks that Vivado knew were required for that. Now our next step is to connect up some of our clocks. I could use the mouse here and then just manually make these clock connections, but what I like to do is go over here to the Signals tab, and I have I can view all my clocks that I currently have. So I'll make this a little bit wider. You see that I currently have two clock domains, the clock 0 at 100 megahertz and the clock 1 at 200 megahertz. Those are the two that I set up in the Zynq processing system. And then I have, looks like about 9 unconnected clocks here. I can click on any of these and it'll cross probe to the location of the clock. So it turns out I want all 9 of these clocks to actually be on that 200 megahertz domain. So instead of connecting these manually, I can simply just drag these and drop them right here in the 200 megahertz clock domain. All those connections are made for me. Now I don't have any unconnected clocks left in my design. So the next step now is to add our video processing pipeline. So what I'm actually going to do here is source a tickle script that I had. This is a processing pipeline that I put together in a previous video. If you're interested in more information on the details of what's in this image processing pipeline, there's another video creating IP subsystems using Vivado IP Integrator. So I can source this tickle script. Alright, let's regenerate the layout here. Okay, so this added 2 blocks. So now I have my image processing pipeline and then also video out. So let's start to make these connections. So I want the output of the image processing pipeline to go into my VDMA, and then I'm going to want the output of the VDMA to go into my video out. You'll notice when I opened up this video out, another designer assistance appeared. This is to connect the AXI4 Lite interface on that video timing controller, which is still unconnected. So I'll let Vivado take care of that for me. Alright, we can collapse that. If we want to take a peek inside the image processing pipeline here. So the video signal comes in, it goes into this block called video into AXI4 stream, and then through the color filter array, a color correction matrix, a gamma correction, and then it gets converted from RGB to YCRCB, and then goes into the VDMA. So while I've got this block open, I might as well just make these connections here for the reset to connect the reset on my interconnect block. Alright, looks like I think I'm done here. Let's collapse this, regenerate this. Diagrams may be getting a little bit busy, so let me create another level of hierarchy here. I can take the VDMA and the interconnect, group these together into a new level of hierarchy, maybe call this my VDMA. And then the remaining blocks, the Zynq processing system, the AXI interconnect, and then this reset. Let's create another level of hierarchy. I can call this my Zynq subsystem maybe. Let's regenerate the layout. Alright, so now we have a nice clean view and visualization as to our entire design. So the input data is going to come in, the video in. This is an interface with our video stream. Get converted to AXI4, go through the VDMA off to DDR memory, and then back, and then come out the video out, and then get converted back to a video stream. So you can see here where it's really convenient to be working at the interface level as opposed to having to manage all these individual signals. That's one of the big benefits of Vivado IP Integrator. Okay, so our next step now, now that I think I'm done with my design, is to run validate design, which does data type propagation and runs an additional set of design rule checks. Oh, looks like I actually forgot to connect two clocks here, so I can open this up in the messages view. You can see how it cross probes. I left that clock and that clock. I forgot to make those connections. So let's do that right now. Connect this to our 200 megahertz domain, and also connect this to our 200 megahertz domain. Now if I look over here in my signals, I actually don't have any unconnected clocks, so those must have been the last ones. So let's run validate design again. Okay, I have two critical warnings. A couple of addresses aren't mapped in the address editor. So let's go in the address editor, expand this. I've got some unmapped slaves. So I'll right click, auto assign. I'll let Vivado take care of doing the address assignment. And let's do validate design one more time. You can see how it's much easier to catch these issues early in the design flow as opposed to catching these much later in the design flow. Alright, validation was successful, so now there's no errors or critical warnings in my design. So let's open this back up. We can look at our design hierarchy. You can see if I have interface connections. As I select these different interfaces, you can see that Vivado is able to cross probe between these. If there's any that I might be interested in debugging later or having extra visibility in, I can right click on any of these and I can mark them for debug, and then that adds a little bug here in the diagram so that I can know that, and then also over here in the design hierarchy. And then when it comes time for Vivado to generate HDL for this diagram, then it will automatically insert the necessary probes for debug during simulation. Alright, so let's go back to our sources view. Our next step now, let me zoom back out here. Our next step now is to create a HDL wrapper for this design. So Vivado is asking if we want to let Vivado manage this automatically. So that's what I want to do, so I'll say OK. And then Vivado now will generate a top level HDL wrapper for this diagram. Okay, so we can come over here and double click and take a look. So this is the top level wrapper that was just generated. So the next steps in our process here would be we would generate the block design. So this will generate all the outputs needed for synthesis, simulation, and implementation. So we could actually run our synthesis and implementation and then generate a bit stream. And then once we've generated a bit stream, we can come up here and we can go export hardware to SDK, and we can launch SDK. And then this will take our entire project and then create a board support package for SDK to enable our software developer to start writing C code that's going to run on the Zynq processing system. So in this video, we saw how we set up the Zynq processing system and connected a VDMA using IP Integrator. Then we added a video sensor processing pipeline in the fabric using a tickle script. We used validate design to run design rule checks on the design. And then we saw the steps to prepare the design for the software developer. For additional information, there are other related videos: creating IP subsystems with IP Integrator, designing with Vivado IP Integrator, and IP Integrator advanced user tips. There are also numerous instructor-led trainings available, and 2 user guides, UG 994, Designing IP Subsystems Using IP Integrator, and then the associated tutorial in UG 995. Thank you for watching this Vivado Quick Take video.